Hello everyone, welcome to your first algebra video. For this video you're going to need to have your notes worksheet, a pencil, and a highlighter. If you don't have those three things, please press pause and go get those now before you start your video. Parlez-vous français? هل تتكلم العربية? Habla español? Hey, wait a minute, I thought this was algebra. Do you speak algebra? Yes, algebra is a language, and this video is going to be about understanding the language of algebra. Let's think about languages for a minute. In a language, we start with letters, and we put the letters together to make words, and we put the words together to make sentences. In algebra, we start with numbers and variables. We put the numbers and variables together to make expressions, and then we put the expressions together with equal signs to make equations. Let's look at our first vocabulary word, variable. A variable is a letter or symbol used to represent a number, and the value of a variable can change. All of these expressions below have variables in them. A variable can simply be a blank. It could be a shape like a square or a star, or it could be a letter. Most often in algebra, we're going to be using letters for variables. Now, when do we use a variable? We use a variable anytime we have something that's unknown, like a number, or an unknown quantity, or an unknown number of people, or an unknown number of hours worked, or an unknown number of miles driven. A numerical expression is a collection of numbers, operations, and grouping symbols. Notice the similarity between the word number and numerical. That's because numerical expressions only have numbers and operation symbols in them. They do not have variables. Now let's talk about algebraic expressions. An algebraic expression is a mathematical sentence containing variables. All of these are algebraic expressions because they all contain at least one variable. An algebraic equation is a mathematical statement that two expressions are equal. So in an equation, we will always have two expressions joined by an equal sign. Notice how the word equal is included in the word equation, because an equation always has an equal sign. So let's look at some examples of expressions. All of these are expressions and equations. All of these are equations. What's the difference that you see between the expressions and equations? If you said the equal sign, you're correct. An expression does not have an equal sign. An equation always has an equal sign. We're going to be learning how to translate phrases into algebraic expressions or equations. And there's certain phrases that we need to know that indicate certain operations. So let's think about addition for a minute. Think of 2 or 3 words that mean addition. Maybe you thought of plus, increased by, or sum, or total. More than, added to. Notice how more than and added to each have 3 stars next to them. Make sure you include those in your notes, and we'll talk more about why these 2 phrases are special in a minute. Let's go on to subtraction. Pause the video and think of 2 words that mean subtraction. Then press play once you have your words. Maybe you thought of minus or decreased by, difference, less than, subtracted from. Again, notice the 3 stars next to less than and subtracted from. These are two special phrases that we'll talk about in a minute. Think of a couple of words that mean multiplication. We have times or product, twice, double. Twice means multiply by 2, as does double. Triple means multiply by 3. Also, the words of and per mean to multiply. What division words can you think of? How about divided by, quotient, ratio? When we split something into equal parts, we're using division. When we're calculating an average, we're also using division. Some phrases are going to tell us that we need to raise something to a power. For example, the square of or squared means to raise something to the second power. The cube of or cubed means to raise something to the third power. We'll also talk about consecutive integers. Consecutive integers are just integers that come one right after the other. So like in our example, 2, 3, and 4. Notice that to get from one to the other, we always add 1. 2 plus 1 is 3. 3 plus 1 is 4. We could also have consecutive even integers. For example, 4, 6, and 8. Notice with our consecutive even integers, we have to add 2 to get to the next one. 4 plus 2 is 6. 6 plus 2 is 8. We could also have consecutive odd integers. They are also separated by 2. 3 plus 2 is 5. 5 plus 2 is 7. Let's look at our last operation word, equals. What are some words that mean equals? Well, obviously we have equals. The word is also means equals in a word problem. You may also say yields, amounts to, or the result is. Now, when we're translating a phrase into an algebraic expression, does order matter? Let's look at two expressions, 8 minus 6 and 6 minus 8. 8 minus 6 is 2. 6 minus 8 is negative 2. So you can see the order that we put the 8 and 6 in around the subtraction sign is very important. So yes, order matters when we're writing an algebraic expression. Most of the time when you're translating, write your expression in the order that you read. There is one exception, and that's our turnaround words. Those were the words that we put the 3 stars next to, more than, added to, less than, subtracted from. Let's look at a couple examples of what to do with turnaround words. 6 more than a number. Well, if I have more than a number, that means I have to have the number first, and then I have to add 6 to it. So instead of writing 6 plus n, we're going to write n plus 6. How about a number subtracted from 4? Why, can't subtract from something unless I already have that thing. So I have to, instead of doing n minus 4, I need to do 4 minus n. So these turnaround words will tell us that we need to switch the order of the numbers and variables on either side of the operation sign. Let's look at some examples. All of the examples that are highlighted in red here are the ones that we're going to be doing together in this lesson. Notice how I've highlighted important numbers. So that's the first thing we need to do when we're trying to translate, is to highlight the words that tell us operations or important variables or numbers. Here we have the sum of a number and 8. We know sum means add. What are we adding? We're adding a number, which we don't know. So we'll represent that with the variable n and 8. Let's go down and do number 3. Pause the video. do number 3 on your own, and then press play. Make sure you're highlighting important words. We have a number, n, decreased by 16. So that's n minus 16. Okay, let's go to number 2. Twice a number equals 6. Twice a number means multiply a number by 2. So we'll write 2n. In algebra, we usually don't use a multiplication sign. We can just write the number in front of the variable, and that means multiply. 2n equals 6. It's your turn on number 4. Pause the video, highlight, and write your expression. 1/2 of a number. The word of tells us to multiply, so we're multiplying 1/2 times a number, n. Number 5, 6 more than a number amounts to 4. Let's look at 6 more than a number first. More than is one of our turnaround words, so we know we're going to be switching the order of the number and 6 here. So that would be n plus 6. Amounts to equals 4. Okay, it's your turn on number 7. Make sure to highlight and be careful of the turnaround word. 10 less than a number. Well, that would be n minus 10. Did you remember to switch the order of the n and the 10? Okay, we're going to do a couple of more examples. The square of the quotient of a number and 7. So notice that we have two operations here. We have square and quotient. So we're squaring a quotient. First, we have to do that quotient before we can square it. So that's why I put the quotient of a number and 7 in parentheses. Quotient means divide. So we have n divided by 7 in parentheses, and then we're going to square that whole quantity. Square means raise it to the second power. Okay, here's another good example. The sum of two consecutive integers is 8. So let's think about an example of two consecutive integers. We have 2. The next consecutive integer would be 2 plus 1, which is 3. So if our first consecutive integer is x, then the next consecutive integer will be x plus 1. What do we need to do with those two consecutive integers? Well, we need to find the sum. So we're going to add together our consecutive integers, and then the answer is 8. Okay, that's the end of our first video. Make sure you bring your notes to class tomorrow for me to check.